Good evening, students. So now in today's video I am going to explain you about electrostatic properties of a conductor. Okay, so let us begin. The very first point is net electrostatic field is zero in the interior of a conductor. So what is the meaning of this? So let us understand this by one example. Suppose we have a conductor and we have kept it in the electric field. So suppose this is a conductor, okay, and we are keeping it in electric field. So what is the meaning of this? Keeping it in the electric field means that field lines, I have drawn the field lines, are passing through it, okay. And now when the field lines will pass through it or will go in this way, then this electric field, imagine this electric field as E external, because this is the field we have applied externally on the conductor. And because of this electric field, this is a conductor. What will be held out? In a conductor there are number of electrons, and the number of electrons will try to come in the opposite direction of applied electric field. So this is why all the electrons will reside on the surface of this conductor like this way. And because of the absence of all the electrons, all the positive charge will reside on this particular end. Okay students, so now as you can see, there is accumulation of all negative charge on one surface and accumulation of all positive charge on another surface. Now because of this, we can say that this is a very low potential and this is a very high potential. And high to low, what is there? There is the electric field present. So one more electric field will be induced inside the conductor, and because this is induced electric field, so I am writing it as E induced. Okay, now these electrons will keep on increasing and these protons also will keep on increasing on the similar way until this electric field which is induced will become equal to E external. So E external will be equal to E induced until that these electrons will keep on residing on the surface. Now when this electric field E external and E induced will be equal and both are opposite in direction, so what is the net electric field inside the conductor? So the net electric field inside the conductor will be how much? Zero. I hope you understood this point now. Now students, second point I am going to explain you. Just outside the surface of charged conductor, electric field is normal to the surface. Now students, electric field is always considered to be the normal to the surface. So what we are assuming this point as wrong one, okay. And we are considering, suppose we have a surface and then in this surface, okay, what is the curvature like this, okay, and electric field is not normal, okay. We are considering that electric field is going like this, okay, and if electric field is going in this particular direction, random direction, so it is making an angle theta with this particular surface, and we already know if it is making an angle theta, then it will have a two components, okay. So because of this, one component will go in this particular direction, okay, in the direction along to the theta, and that is known to be E cos theta, and one component which is perpendicular to this, so E sin theta. Now students, if E cos theta exists, that it means so this E cos theta should be equal to 0. Why this E cos theta should be 0? Because already we have studied that net electrostatic field in the interior of conductor is 0 and it is coming from the interior. So E cos theta should be 0, and when E cos theta is equal to 0, cos theta will be 0, okay. And what is the meaning of this? Theta will be how much? 90 degree. So that is why we can say the electric field is always normal to the perpendicular to the surface of the conductor. I hope you understood this point now. Now students, third point is the net charge in the interior of a conductor is 0 and any excess charge resides at its surface. How we can solve this problem? We can solve this problem by applying Gauss theorem. Okay, Gauss theorem tells us that flux coming out is 1 upon epsilon naught time the charge enclosed. Okay, and what we have studied? just outside the surface of charged conductor, electric field is normal and electric field is 0. If electric field is 0, then flux will be how much? Flux also will be 0, and flux is 0. If flux is 0, what will be the value of charge? Charge also will be 0. So that is why inside the conductor the charge is 0. Now the question is, if the charge is 0 inside the conductor, and suppose I have a rigid body and I have placed one particular conductor, okay, hanging in this particular way. Now suppose I am giving the extra charge, Q charge I am giving. So that cannot go inside, as we have studied by Gauss theorem. So where that charge will reside? So the answer is that particular charge, the amount of extra charge which you will give, that will only reside on the surface of the conductor. More and more charge you will give extra amount, and more charge will reside on particular surface only. I hope you understood this point. So extra charge is on the surface only. Now students, the fourth point is potential is constant within and on the surface of conductor. How we can solve this problem? We can solve this problem by using one mathematical way. So what is electric field? Electric field is E is equal to minus dV upon dr. Electric field is equal to negative potential gradient. Okay, now what is the value of electric field? We have studied that electric field is 0 for a conductor. So 0 is equal to dV upon dr. Now students, you already know mathematically which physical quantity's differentiation is going to be 0. The differentiation of the physical quantity, which is 0, is actually a constant one. So potential should be constant. Okay, if electric field is 0, then potential should be constant. I hope you understood this point. Now students, fifth point is electric field at the surface of charged conductor is proportional to surface charge density. For understanding this point, I already have drawn one figure. So suppose we have a surface. Okay, on this particular surface we have a very small cylinder. Okay, and this small cylinder is partially inside the surface, partially outside the surface. Suppose the surface which is out is del S. Okay, so we have to imagine about this particular del S as this is a Gaussian surface. Okay, and according to Gauss theorem, we can apply the Gaussian surface, means Gauss theorem later on. Phi is equal to E del S, this we know. Okay, charge, what is the charge enclosed? If the surface charge density of this particular is sigma, I am considering the surface charge density sigma, then what will be the total charge? Total charge will be sigma surface charge density into area. And what is the area we have considered? Del S only. So Q is equal to sigma, in place of area there will be del S. Now apply the Gauss theorem. Phi is equal to Q upon epsilon naught. In place of phi we can write E del S is equal to, in place of Q, sigma del S upon epsilon naught. Del S and del S gets cancelled out. So what is the value of E? E is equal to sigma upon epsilon naught. This is in the mathematical way, scalar way. And for giving it the direction, so there will be n cap. What is n cap? N cap is a unit vector, and this n cap unit vector is following the same direction as that of electric field. So you can see clearly E is equal to sigma upon epsilon naught, and E is proportional to sigma. So more will be the surface charge density, more will be the electric field. Now students, the sixth point is electric field is 0 at the cavity of hollow charge conductor. We have a hollow charge conductor. Already nothing is present. If nothing is present, electrons are not present, charges are not present, Q is equal to 0. If Q is equal to 0, what will be the value of E? Electric field also will be 0. So these are the properties of a conductor. I hope you understood all the topics, and written notes of these particular topics I will provide you. So thank you. God bless you.